about hybridization? Have you anything?
Yes, sir.
What is meaning of hybridization? Do you know?
I know a little.
Okay, okay. Tell me.
So I like
Mhm.
S SP 2 SP 3
Yeah.
hybridization sathi hu.
Good, good, good. Hybridization means intermixing of orbital, right?
Intermixing of orbitals.
Intermixing of orbital, and that is of the same atom. This is also of the same atom. That is the concept of the same atom. So if you talk
Yes.
about the hybridization, it is intermixing of orbital. That is the very basic one. Okay. Up now, let's try
Okay,
to
sir.
understand hybrid. No, you know hybrid. Hybrid means that is too many things are combining and generating. That is the identical things. That is what hybrid. Okay. So let's try to write
Yes,
down
sir.
the definition of hybridization. Okay. It is
Yes, sir.
it is process of, they are saying it is process of what? Process of intermixing of, it is process of intermixing of two or more than two orbital, two or more than
More than two
two
orbitals.
orbital, two orbital of the same atom, of the same atom, they are saying of the
No,
same atom, intermix together, intermix together, intermix together, together to give same number of new orbital, same number of new orbital, intermix together to give same number of new orbital, they are saying
no
same,
orbitals.
same number of new orbital having, what is the quality, they are saying having equal energy, you know. Yeah, you can write in spite of writing equal energy, the word is having similar energy, similar energy and similar shape, similar energy
Mm,
and similar shape. That is what the point.
yes.
Okay, similar shape. This is what the definition of hybridization. Again, I am trying to explain you. It is the process of intermixing of two or more than two orbital of the same atom, uh, same atom intermixed together to give same number of new orbital having similar energy and similar shape. Okay, is known as what? Hybridization. These are the point which are very, very important. Let me try to explain you. See, if I am taking that is carbon, okay, I am taking the carbon. So carbon, if you are taking that is, what is atomic number of carbon, Janab? Do you know atomic number of carbon is 6? Okay.
It's six.
I am going for the ground state configuration. Here is, this is the ground state configuration. What is ground state configuration? This is 1s2. This is going to be 2s2, and last one is 2p2. So Janab, you can see here if you are doing the distribution here, so 1 and 2. Okay, and here is if you are talking about,
Yes, sir.
so 1 and 1. Okay, now
Okay,
here
sir,
only,
can you explain this?
this is the above principle now, atomic structure. So one orbital configuration, do you know or don't know orbital configuration?
No, sir, can you explain me once, please?
Okay, orbital configuration. Orbital configuration, Janab, orbital configuration, how they said configuration, they are talking about that is filling of electron, filling of electron, okay, filling of electrons in various orbital is according to, they are talking is according to increasing order of energy of, is according to increasing order of, increasing order of energy of orbital, increasing order of energy of orbital, right? This is what the point, increasing order of energy of orbital. Now if you see that is s, no, orbital, I am writing here orbital, and maximum electron, here I am writing maximum electron. Okay, so there are four
Yes,
types of orbital are there, if you are knowing, and each orbitals are subdivided. Suppose this is s orbital. So s orbital, if you talk about, maximum electron is 2. Okay, if you talk about the p orbital, okay, so p orbital can have the maximum electron 6. If you are going for the d orbital, okay, this is the d orbital. So if you talk about d orbital, so maximum electron is 10. And if it is the f orbital is the maximum electron is 14. What is energy order, Janab? That is energy order is 1s, then 2s, then 2p, then 3s, then 3p, then no 4s,
4P.
no
4S.
4s, 4s, then
Sir,
3d.
why 4S?
This is the given by
Sir, I
above
didn't understand the order.
order
Sir, can
order
you explain me this?
order. You see, this is the concept. Here is 1s is there, then 2s, 2p. Then here is it is going to
Okay.
3s, 3p, 3d.
3P.
Then it is 4s, 4p, 4d, and 4f. Next one, 5s. Here is 5p. Here is 5d and 5f. Here is 6s, 6p, 6d. Last one is 7s, 7p. These many orbitals are there. Now, how the electron? Firstly, electron will go in the 1s orbital. Then it is going to which one? 2s orbital. Then it is
Yes.
going to be 2p orbital. Then it is 3s orbital. Next one, it is going to be, you can see here is 3p, then 4s. Then here is coming
Yes.
3d, 4p, 5s. Okay, now see, the first one is coming 1s, then it will come 2s, then it is coming 2p, then it is coming 3s, then it is coming 3p, then it is after 3p, which one is coming? 4s, yes or no?
Yes, sir.
4s, then it is coming what? 3d, then it is coming 4p,
3D.
then it is coming 5s.
Yes,
Are you now, are you be able to understand?
sir.
Okay,
Yes.
this is increasing order of energy. This is increasing order
Yes.
of energy of orbital. Energy of orbital. Okay, this is the point. Increasing order of energy of orbital. Can you
Yes.
be able to understand this one? So here, so suppose you are going for the
Yes,
carbon.
sir.
Carbon. So carbon is 6. 6 means how much? That is 1s. How many electron will go s orbital means 2 electron. So 2. Then it is going to be 2s. 2s, how many electron? Again s orbital 2. Then 2p. So total 6 electrons are there. To 4 filled. How many left? 2. So 2 electron. Are you be able to understand this?
Yes,
2,
sir.
2 electron plus 2 electron plus 2 electron is equal to 6 electron, and 6 electron is equal to this number. Yes or no? Is
Sir,
it
can you explain this carbon once more?
carbon? See, it is the 6 electron. No, total electron is 6. 6 electron. So here is what is this is s orbital. So s orbital will take how many electron? 2 electron. Then again s
Electrons.
orbital, how many? 2 electron.
2
So
electrons.
out of 6 electron, 4 is filled. 2 to 4. Yes or no?
Yes.
How many left? So total was 6,
2.
4 already filled. So how many left? 2. 2 electron left, na? So 2 electron will go
Yes.
in this orbital, p orbital, because increase our energy to 1s, then 2s, then 2p. So that is remaining will go in the 2p orbital. Are you be able to understand now?
Yes, sir.
I'll share the rule for electronic configuration to you. Right?
Okay, sir.
So here is carbon. If you are going 6, it is the known as excited state. Oh, no, this is going to be excited state. So if you are sending this one excited state, so one electron will jump here. This is called that is excitation. Excitation, right? So if you are
Yes,
excited,
sir.
so this is will be 1s2. Only balanced electron is participating, not other electron. This is inner orbital. So here it will be now 2s1 and 2p3. So this is the one
Yes, sir.
electron. Here is what is there. This is the one. Here is one. Here is one. Now, if you are knowing the
Okay.
shape of s orbital is spherical, okay, atomic structure you need to study. This is the s orbital. Shape of s orbital is spherical. Then what is there? P orbital. P orbital is dumbbell shape. So this is the px. Next one is py orbital. So y axis. This is the px because the axis is x. This is py because axis is what is there. This is y. Okay. Last one is pz because axis, if you are talking about, this is the z axis. Okay. This is the z
Yes.
axis. Okay. This is the py. Now they are having different shape, right? So what they are going to do, they are going to intermix. They are going to intermix. Now it the intermixing. Okay. If they are intermixing, so they are going to be 4 orbital are intermixing. So 4 new orbital will form. After there, we are writing this position. So see, the 4 orbital will be like that. This is the 1 orbital. Then again, it will be that is similarly 1 more orbital. Total 4 orbital we have to draw. This one is there, and then this is there, 4 orbital. These 4 orbital, what they are arranging themselves, in what manner they are going to arrange? Okay, see, this is the tetrahedral manner they are going to arrange. 1 here, if you are going, this is going to be 2. Next one, if you are going this one, this is going to be 3. Last one, if you are talking about, this is going to be 4. Here this is 4. Then you can match. If you if you are matching now, all orbital are equal size. Okay, this is now this is what is degree. If you are talking about 109 degree 28 minute, what is shape? Tetrahedral shape. Tetrahedral shape. Tetrahedral
Yes, sir.
shape. Okay, now this intermixing. So what orbital intermix? So one is the s orbital. This is the s orbital. And p, then next one is p. How many p orbital are there? Px, py, pz. So this is sp3. Yes or no?
Yes, sir.
So this is called sp3 hybridization. This is the sp3 hybridization. Can you be able to understand this?
Yes, sir.
Okay, so will you write this, Janab? Will you write?
Yes, sir.
So from this page you need to write. If you are writing, then it will be helpful to you only.
Yes, sir.
Hmm.
Yeah. Yes,
Done.
sir. This page I wrote.
Okay, thank you. Next page I am going. Huh. You done? Done, Jana?
Writing, sir, writing.
Okay.
Done, sir.
Okay. So this is all about the concept of hybridization. Okay. This page, what you will do?
Yes.
You want to write this?
Yes, sir.
Hmm. It's taking time here. See, when
Sir,
huh?
one s orbital, one p orbital.
Yes, correct. When one s orbital and one p orbital, one s orbital and one p orbital, okay, intermix together. Here it is going to be intermix together to form, okay, to form two new orbital, okay, two combining means two will form two new orbital, two new orbital of similar energy and similar shape, similar energy and similar shape, similar energy and similar shape. This is there, similar energy and similar shape, right? So is called sp hybridization, is called, what is going to call, is called sp hybridization. Okay, sp hybridization. Now if you talk about point number one, shape of, they are talking about some point, important point they are talking about, shape of what, shape of sp hybrid orbital. Okay, shape of sp hybrid orbital, what is there, that is linear shape. Okay, two orbital means linear shape, है ना, linear shape. If you are talking about linear shape means straight. Okay, if you are talking about linear shape means straight. Second one, bond angle, they are saying bond angle between no, bond angle in sp hybridization, in sp hybridization, what will be bond angle, can you guess? Bond angle if linear shape is there, bond angle in,
Sir, 180.
yeah, thank you very much. Okay, so sp hybridization bond angle is 180 degree. Third point, example if you are going, that is BeCl2, this is on example is there, and C, they are talking about CH, no, C2H2, you can write C2H2, this is there. Okay, etc.
Yes, sir.
So let us try to understand this one. Okay, here I am going for the BeCl2, I am taking Jana BeCl2. So only we are talking about Be atomic number is 4. So configuration, if you are writing this is 1s2, then it will go 2s2,
Yes, sir.
and here is then 2p, 0 is there. But if you see here, how many electron is there in valence shell? 2 are valence shell, 2 electron. Here there is no electrons are there. But how many bond form required? That is 2 bond required. So for 2 bond, 2 unpaired electron also required. So this configuration is called, that is ground state configuration. Now what we are sending, this is Be4. We are sending this one excited state. This is going to be excited state. If you are sending excited state, so this electron is going to jump here. This is called what? Excitation. This is called excitation. So what will be the configuration? 1s2, then 2s1 and 2p1. Here that is 1 electron. Here you can see how many electrons are there. This one. If you see the shape is earlier shape is what is, this is the dumbbell shape. Okay, and this is the spherical. Okay, so this is the s orbital. This is s orbital. Okay, and this is going to be p orbital. Ab Janab, they are going to intermix together. So what type of intermixing will go? Intermixing. What type of intermixing? What would be the name of? Uh,
Sir, SP orbit
SP.
hybridization.
Yeah, thank you very much. So it is going to give undergo, that is SP hybridization. So when they are going SP hybridization, Janab, so they how many new orbital will form? 2, because 2 combining OS and P, so they will form 2. So the new orbital will be like that. Suppose the orbital, how we can write that is, let me try to draw it. Okay, so this is the orbital. Okay, and one more orbital is there. Okay, here. So 2 orbital are there. 2 orbital, how they are going to arrange here? See, so this is 1, then here orbital is there again, so it is going to be another orbital. Now you can see that is 180 degree, na, they are arranging 180 degree. So this is the what will be, that is 180 degree linear shape. Now what they are saying, we are having chlorine also. So chlorine also, chlorine have p orbital. Okay, chlorine last. So chlorine, where they are going to overlap? So here see, this is the sp hybrid orbital. Here that is chlorine orbital is going to combine. So this is the Cl orbital. This is Cl. Again this side going to be what? This is going to be Cl. This is again Cl. So here what is bond is forming? That is sigma bond. This is sigma bond, because head to head overlapping. This is again going to be what form? That is sigma bond. So sigma sigma bond. Now you can also you can write that is, or how can we write? So that is, here is B is there. This side what is there? Cl. This side what is there? Cl. What is the shape here? You can say 180-degree. So this is the linear shape. Can you understand this one?
Yes, sir.
Okay. So will you please write down this one, Sp hybridization concept?
Yes, sir.
Hmm. Then Zainab, completed? Hello?
Last part, sir.
Okay, okay, no problem. Electron required? 3 bond means 3 unpaired electron. 3 unpaired electron required. How many unpaired electron is there? We are having only one. So we are exciting this one. If you are excited, so let's try. This is the ground state configuration. Ground. So after exciting, that is boron 5 is there. It will be that is 1s2, then it is 2s1, and then here is 2p2. So here configuration is 1. Here you can see this one is what is there. Here is this one, 3 unpaired electron. Now the s orbital shape is the what is spherical. Here is p, this is going to be px orbital, then it is going to be p orbital, always having the different shape and energy. So they are going to intermix. Okay, they are going to intermix. So what type of intermixing will be there, Janab? Can you please tell me? What type intermixing will be there? Three orbital intermix.
Yes, sir.
So 3 orbital intermixing. So one s is there. How many p are there? 2p. So it will be sp2 hybridization. Yes or no? Yes. So is it audible, Janab, to you? Audible?
Yes. Yes,
So
sir.
so 3 new orbital is going to form. 3 new orbital. You can make is 3. Okay. Here is 1. Then it is going to be, here is the 2. Then here is, it is going to be what? It is going to be 3. These 3 orbital, how they are the rearranging themselves. You can see the first orbital. If you see, this is the one orbital, then another orbital, how they are going to arrange this way, and next one how it is going to arrange this way. So if you see the shape of this orbital, how it is going to look like, so this is the trigonal planar shape. Here is, okay, this is going to be trigonal planar shape. Yes or no? If you are talking about bond angle, you see the bond angle, how much will be there? Bond angle is 120 degree. Okay, so this is shape is trigonal planar shape. Trigonal planar. Up now, planar shape. If you talk about the, this is going to overlap with the Cl orbital. So how it is going to overlap with the Cl orbital? So here you can see, this is there B, and the Cl is there like that. P orbital of Cl is going to overlap. So it is the Cl. Here you can see this one. So this is going to be Cl. Here you can see this one. So this is going to be the Cl. So here is Cl, you can write, and here is also Cl. So let us try to write down. Here is Cl, this is going to be Cl. So here is, this is the Cl, this is the Cl, here is, that is Cl. You can check this one, how the bond are getting arranged. Here is how the bond are getting arranged. Here is bond are getting arranged. So what is the angle? 120 degree. This is shape is what? Trigonal planar shape. Trigonal planar shape. Trigonal planar shape. Right. You can make this one like that. So boron is there. Here is Cl. Here is Cl. Here is Cl. You can make it out. Okay. 120 degree. Can you make a diagram, Janab, here? From this side, can you write sp2 hybridization?
Yes, sir.
Done?
Yes, sir.
Okay. This page also you please write.
Yes, sir.